So let's use the circle, the unit circle, to look at the sine of the angle in more details. So here we have an angle of 30 degrees, which gives us a sine of 0.5. Now, if you look at this yellow dot, okay, on the right hand side here, on this Cartesian plane, this coordinate diagram, the x-axis is the angle. So if I move along here, the angle is changing. So we're going from 0 to 90 to 180 and so on. Okay. You notice the height of the graph, or in other words, the y-axis, is telling us the sine of the angle. So what we're graphing here is the sine of the angle on the y-axis as we move through degrees, angles on the x-axis. So you'll notice that the yellow points are in line with each other. Let's trace this graph, see what happens. So obviously down here there's no height of the triangle, so there's no sine. The sine is 0. As we move through, it starts to get higher and higher and higher until we hit 90 degrees when it's at its maximum. So that's at 1 there. As we keep on going through now, it's going to start coming back down to 0, and it does that at 180 degrees. So now the height of the triangle is going to increase, but we're going into negative coordinates. So we're in negative coordinates down here. So it's getting bigger. The distance from 0 is bigger, but we're going more and more negative until we hit -1. And then we start to come back towards 0. So after one full revolution of a circle, we have a full sine wave. So the sine wave starts here at 0, goes up to 1 at 90 degrees, goes back to 0 at 180 degrees, comes down to -1 at 270 degrees, and then when we hit 360, one full revolution, we're back to 0. So a full sine wave goes up, down, and back to the middle in one full revolution of the circle in 360 degrees.